Hind friends, myself Sachin Jain, Assistant Professor, Department of Computer Science and Engineering, Garg Engineering College. So, for today's lecture, there is a topic is phases and passes. That is the fundamental topic of compiler design. So, these are the outlines of today's lecture. We will discuss what is compiler versus interpreter, preprocessor, compiler, assembler and linker, phases of the compiler, analysis synthesis model of the compilation, and passes of the compiler. So, what is compiler? A compiler is a translator that accepts source program that is written in high level language, that may be either C or C++, and convert it into the object program or low level language such as assembly language. So, there are various activity by the compiler, like the syntax error are identified and appropriate error messages are displayed within the line number. So, it doesn't only convert the source program into target program, but it also does the error display thing along with the line number. The second thing that compiler does is the optional list file can be generated by the compiler, and compiler replaces all the executive statement into the high level language or one or more machine level language instruction, and it convert high level language into machine level language or object program if program is syntactically correct. So, this thing is done at last. If there is an error, it will display an error, it will create the optional list, it will replace the executive statement into the machine level language statement. So, in this manner the compiler works. Now, there is a difference between a compiler and an interpreter. So, there are a few differences, like compiler take entire programs as an input and convert it into the output. It take single instruction as an input and it converts single instruction into the output. So, it does the whole program, it does line by line or instruction by instruction. Compiler is faster because it does whole program conversion into machine level language in a single time, or it is slower. Intermediate object code is generated here. Here no intermediate code is generated in case of interpreter. It require more memory because intermediate code is generated here. So, that's why memory consumption is high, but it require lower level of memory consumption because every time higher level program is converted into the lower language program. Program are need not to be compiled every time in case of compiler, but in case of interpreter, debugging is quite easy. Error are displayed after entire program is checked. Here error is displayed. If there is an error in a single line or instruction, it will display an error. So, Python or Ruby are the perfect example that uses the interpreter, and here C and C++ are the perfect example that uses the compiler. Now, there are some compiler that are kind of hybrid compiler. Hybrid compiler are the compiler that are the combination of both compiler and interpreter. The compiler may produce intermediate level code which is then further interpreted using the interpreter and then compiled to the machine level language code, for example Java. So, Java is a programming language that uses the both kind of translator, compiler as well as interpreter. So, let us see how it works. So, the source program is given to the compiler, and then compiler generate its intermediate program, and this intermediate program is further given to the virtual machine that's called JVM, Java Virtual Machine, that takes this intermediate program as an input and produce the object code or output, that is the actual required code. Now, there is few things that we should know before knowing how compiler works, like what is preprocessor, linker, compiler, assembler, and the role of these all the terminologies. So the source program is given to the preprocessor. Preprocessor just does some preprocessing, or it embeds some files if there are some files required. Then after doing pre-processing, this program is given to the compiler. Then the compiler converted it to the target program, that can be the machine level language program or the assembly language program. And then linker actually link this relocatable object code, and then finally and it's also link the libraries and other files if required, and then at the end absolute machine code is generated. Now, the next topic of today's lecture is the phases of the compiler. So basically in this diagram we can see that there are 6 phases of the compiler. First one is lexical analysis, second one is syntax analysis, third one is semantic analysis, fourth one is intermediate code generation, fifth one is code generation and code optimization, and then finally code generation. So source program is read or given as an input to the lexical analysis phase, and then lexical analysis phase divided into some tokens. Then these tokens are given to the syntax analysis phase. It generates the parse tree. Then syntax tree, this phase will generate. Then some intermediate code representation will be done through intermediate code generation. Then optimization will be required. Then optimization phase will work, and then finally code generation page actually generate the target program. So all the phases you can see in this diagram, all the phases are connected with the error handler. If there is some error in this entire phase or in this entire step, then the error handler will actually handle those error, or it will generate those error to the programmer. Now, all the phases here we can see, all the phases are connected with symbol table. Symbol table basically a data structure for the compiler that actually store the data, and that may be accessed during the compilation, before the compilation, after the compilation, and all the data is stored in this symbol table. So symbol table is a data structure, and it is accessed by all the phases of the compiler, all the 6 phases of the compiler. And in this example, we can see the phases that come in starting, that is lexical analysis, syntax analysis, and semantics. So these 3 phases are also called as the analysis part of this compiler, and last 3 phases are called as a synthesis part of the compiler. Now we can see this diagram with an example. Here the instruction that is given as an input to the lexical analysis. Then this lexical analysis divides this single instruction into some tokens, like this is one identifier, this is another identifier, this is another identifier, this is another. So this single statement is divided into set of tokens. Then these tokens are further utilized to generate the parse tree. You can see here the parse tree generated by the syntax analyzer. This parse tree is further annotated, or you can say further decorated, or it can be meaningful with the help of when we pass it to the semantic analyzer. Here the program is divided into the some temporary representation. So intermediate code generates the temporary codes that further may be utilized, or here we can see there is a 3 address code instruction. So the single instruction is divided into some intermediate code representation here through the intermediate code generator, and then code optimizer will utilize these instruction and further optimize the code, and further final code is generated by the code generator. So in this way these 6 phases works: 1 2 3 4 5 and 6, and all the phases access the symbol table, all the phases access the error handler. If there is an error, then it will display an error. If there are some data structure required, then it will access the symbol table. Now another part of today's lecture is analysis and synthesis model of the compilation. So in this diagram we can see there are 2 parts of this phases. One is analysis part, second one is synthesis part. So this is actually the analysis synthesis model of this compilation. So the compilation whole process is divided into 2 parts. One is analysis part, second one is synthesis part. Analysis part determines the operation implied by the source program which are recorded in a tree structure. So we can see that in the previous diagram, here we utilize the parse tree or syntax tree from the given instruction or given program, and the synthesis part takes the tree structure and translate into the operation into the target program. This tree kind of structure is further taken by last 3 phases of the compiler, and actually it utilize to generate its required target code. So these 2 parts, analysis and synthesis, are also called as a front end and back end part. So analysis part is machine independent front end part, and synthesis part is a machine dependent back end part. So sometimes it may be asked that what is front end and what is back end part of the compiler. So back end is a synthesis or front end is a analysis part. So here we can see this is analysis part and this one is the synthesis part. Now passes of the compiler. So when we group the different phases of the compiler, or we just combine the various phases of the compiler, then it becomes passes. So passes is just a collection of phases that may be repeated only once, that can be a single pass, or if it repeated multiple times, then it's called multi-pass system. So single pass usually require everything to be defined before using the source program, or multi-pass system is a compiler may have to keep the entire program representation into the memory. So we can see in this example here all 6 phases are grouped into a single pass. All phases are required. All phases are just combined into a single pass. So this is called single pass or one pass compiler. So, and if we are combining phases like this, like first 4 phases into a single pass, and then code optimizer as a second pass, and code generator is a third pass. So this type of model is called as a 3-pass compiler. So compiler basically Compiler phases basically can be grouped into different phases, and these phases then grouping is called as a passes. So one pass, two pass, three pass, or multi pass compiler. When we just combine these single phases into different passes, then it will be called as a multi pass system. So that's all for today. Thank you.